So we're in 5.1 and we are still doing the graph of a reciprocal function. So in this example, I'm telling you, I'm starting with the linear 2x minus 3. The reciprocal would be 1 over 2x minus 3. So literally take it and reciprocal. This one is a quadratic. The reciprocal of it would be 1 over, and then you flip that to the bottom. That's it. Okay, so the reciprocal function of the original. Reading the question, it says determine the zeros of the original function. So make sure you're answering the question asked. Determine the zeros of the original function and state the equations of the vertical asymptotes of the reciprocal function. So one more time, we learned that whenever it hits the x-axis, it becomes a vertical asymptote. So from over here, every time that the original function, see this blue, hit the x-axis, it became a vertical asymptote. So every time the original blue function hit the x-axis. So if I give it to you without the graph, you're going to take the original function and you're going to set it equal to 0. What are you finding? You're finding the roots. So you want to find the roots, right? Or the x-intercept, right? So you're finding the root or the x-intercept, and then you set that equal to 0 of the original function. So wherever the original function equals 0, like that, the original function equals 0, that will be the vertical asymptote of the reciprocal. Does that make sense? That'll give you the 0 of the denominator of the reciprocal. So let's solve this one. So 3 equals 2x. Divide both sides by 2. 3 over 2 equals x. So then you're going to say, therefore, for this guy here, the vertical asymptote is going to be at x equals 3 over 2, because it's the 0 of the denominator. Does that make sense? So the 0 from the original function is the 0 here. So this translates to the 0 in the denominator there. So then you go find the 0 and say, yep, from there I know that'll be where my vertical asymptote is. So it's very wordy, but when you do the math, you go, oh, that's all. So again, for the original function, wherever this quadratic hits 0, right, wherever it hits 0, I want to know where that is, because on the reciprocal here, that's where the vertical asymptotes are going to be. So I'm going to take this, set it equal to 0, solve it. So x equals 2 and 1. Okay? So then therefore from here, right, from that denominator, I know therefore. So don't just leave it there. Actually conclude it, because otherwise I don't know if you just stopped your answer and went, I don't know, what did I find? You want to say therefore the vertical asymptote is going to be x equals 2 and 1. Right? So I want you to conclude your conclusion here. So answer the question asked. You want to be clear now, right? So your answers at this point should be at a grade 12 level, right? In grade 9, we keep teaching you this. And again, with the 9s that I'm trying to show the lessons for, we're trying to show them the process and the steps and be clear. So you guys have to be clear with what you're answering. Okay, next one. We have, that's okay for those ones? All right, here. I graphed some graphs. These are not all parabolas, right? So it doesn't have to just be a line and a parabola. So these are our kind of thinking questions, but we give you some practice with them. So I go, okay, how can you apply your skill that you know with a linear and a quadratic reciprocal and apply it to now any shape, right? So these are kind of our thinking where we go, okay, now think beyond. So here are 4 steps. So the 4 steps I taught you in the other lesson, 4 steps. It doesn't matter the order. One of the steps was, well, 2 of the steps were asymptotes. There's a vertical asymptote, horizontal asymptote. The other step was invariant points, and then there's also max-min, right? So there are 4 steps. So the 4 steps, I'm going to start with invariant points. So wherever you see it equal to 1, you find that point and put a dot. There you go. Okay. How about -1? Is there any part of the function I can dot? No. And so what you're doing is you're looking, right? You're saying, okay, anywhere that the function crosses at 1, I'm going to dot those points. Anywhere at -1, there's nowhere there. Okay, so invariant points. Remember, there's 4 steps. So invariant point, I did 1. Then it's asymptote, asymptote. There's 2 asymptotes. Vertical asymptotes are my fave because they're the easiest, right? And all you want to do is draw my vertical asymptote. Wherever the function equals 0, I draw a vertical asymptote. Dash, 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 dash. And here, as soon as you draw it, label it. Draw and label. So x equals 5. And here, wherever it hits the x-axis, you're going to do a dash, 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 dash. I know that my dot and my asymptote are very close. These graphs are all going to be kind of squarish. Do the best you can. So that way, if I see the dot and the asymptote, good enough. I know it's very squarish, and it's the graph is going to look kind of overlappy, but I can read it. Okay, so wherever it hits, so vertical asymptote. Now horizontal asymptote. Horizontal was a little bit trickier. Horizontal occurred when, so say the linear, it kept going away from the x-axis forever, like with an arrow. That means it's going towards, the reciprocal means it was going towards the x-axis forever, right? So as it goes away forever, it was going towards. Here on this side, as it was getting closer to the x-axis, it was actually turning around and going the other way, okay? Is there any of that happening on this graph? Is there anywhere where the graph is going away, so it's going to go towards? No, right? So there's none of that away, which means towards. But here, it's going towards the x-axis, which means the asymptote's going to turn away, right? So it's reciprocal, so it's backwards. So as it gets closer to the x-axis, it's going to turn away and head up. Okay, so then there's no horizontal asymptote here, so I don't have to draw one on this side. It doesn't happen. I'll go over it a couple more times, right? So in case the horizontal is kind of tricking you, we're going to do a few more times here as well. Okay, so horizontal is when it heads away forever, which means it's heading towards, right? And again, it's 2. Reciprocal of 2 is 1/2. Reciprocal of 4 is 1/4. Reciprocal of 5, 1/5, 1/10, and it keeps getting closer versus away. So that's what I mean by away from the x-axis. So away means it's actually going towards. Here, closer means it's heading away. But is there anywhere where it's heading away and I need to do a horizontal asymptote on this graph? No. Okay, so no horizontal asymptote. The last step, so there's 4 steps. Asymptote, asymptote, invariant point, max min. So the max min, so if there's a max on this one, so there's a max at 0.5, right? I don't need to see that. Okay, I don't need to see that. What I need to see is that on the reciprocal, it's a minimum. The minimum is going to be, so I want to see this, min at 0.1/5. And you can just draw it and then put a little arrow, and I know your dot is going to be literally sitting on top of the axis because I can't draw 1/5. So you're just going to label it, min, and then draw the dot. And you can put it beside it or put an arrow, up to you. Okay? Now, let's draw it. So that's all the information I have. So those are the 4 steps. Asymptote, asymptote, max becomes a min becomes a max, and invariant points. So I'm going to head over here. So I'm going to curve this over and try to make this curve towards there. It's like the widest parabola ever. It's all going to look boxy like this too. A lot of the graphs end up looking boxy. And then here, as the x, y values are heading towards the x-axis, it's doing the opposite because it's heading away. So it's going to follow up here. Like that. See how it looks like a box? It's very, very squarish. That's just the way it goes. So as long as I see the dot, right? So you show me the dots, that dot, and then this. Okay, so just make sure I can see this dot and that dot because that's your invariant point, and you do the best you can. And you're always like, oh, it feels a little messy. It just feels really wide. Does that make sense? All right. Questions with that? Let's try it again. So let's look at this next one. So one more time. Invariant points. My invariant points are anywhere where the graph equals 1 or -1. So looking across, it's going to be here and here. Good? Anything here? No, nowhere it's going to cross. So invariant points. Asymptote, asymptote. Asymptote, asymptote. Wherever it hits 0, it is an asymptote. So we're going to do an asymptote here. Whenever you draw it, label it. So this will be at x equals 2. Draw and label. Draw and label. Okay. Whatever's a max is now a min. Whatever's a min is now a max. Okay. So I have a min at 2, 0. I don't need to see that. I need to see the max. What's the max then? 2. What's the reciprocal of 0? No, not 0. Undefined. Can't do. Right? Undefined. Can't do it. How come? I just drew an asymptote through that. I cannot do a min or a max at an asymptote. So no, none. So you're going to cross that off and go, no, silly. So this is a special case, right? So the explanation I had from the other lesson was every max becomes a min, every min becomes a max, except if it's at 0. Because if it's at 0, it's an asymptote, so it becomes nothing, right? There's always that but. Yes, so this is one of the but cases. Yeah, so a min becomes a max becomes a min, unless it's at the y value of 0, because then you can't, because it's already an asymptote. So done. Can't do that max min. Now, asymptotes. Did I do the horizontal asymptote? I didn't. So as it heads away forever infinitely, it's going to head towards. It's the reciprocal. So as the numbers get bigger, it's going to get smaller and get closer and closer to 0 but never reach it. So yes, there will be asymptotes, a horizontal asymptote. Draw it, label it. Draw and label, draw and label. You have to label it. Don't lose any of these marks. Draw and label. Okay. So yes, as it goes away, as the numbers get bigger, so say that's 6, it's 1, 6. 7 becomes 1, 7. 8 becomes 1, 8. It's getting slowly lower. So when I draw this lovely thing, I'm going to draw it in pink here. So we're going to do this. So as this is getting higher, it's actually going to do lower, like that. As the numbers are getting closer to 0, so it's 1/2 becomes 2, 1/4 becomes 4, it's going to head up. Yes?
Miss, if there were no arrow on the end of the asymptote,
Oh, I'm going to show you that.
would there
Like
still be
here?
asymptote?
Like here?
Yeah.
Oh, yeah, we're going to do that one. So we'll talk about that in a sec. Yeah. No asymptote because it stops. And I'll show you that in the next one. Yeah, good question. So the question is if there's a dot, and we're going to do that on the next example. Yeah. Okay, so then here, right? So again, as the arrow heads away forever, it's going to head down towards it forever, arrow. And then here, as the numbers are getting smaller, 1/2, 1/4, it's getting bigger. So up, 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 like that. All right, that's it. And exactly now that you are pros, so does that make sense? All right, so towards away. Let's do, my shape from, I don't know. Like, oh, you're good with that? You're good with that? And now I just threw everything at you. Okay, so let's do every possible shape. And yeah, I did a dot. It was like, what happens if there's no arrow? So that makes sense. So now we've got all the theory. We've got this, right? So no matter what I give you, you take that theory and we're going to apply it again. Okay, so now we've got all the theory behind us. We're good for this. No questions with that? All right. All right, let's move on to, I gave you everything. So start with the invariant points. I mean, you can start anywhere. Again, the 4 steps, it doesn't matter the order. I just go through and find everywhere where it's 1. I go through and I go 1 here, 1 here, 1 here. Wherever there's a dot, 1, I drew a dot. I also do the -1. And here, there is a -1 here. Sorry, my arrow kind of got on top, but let's put the dot there. Can you see the first dot here, everyone? I know my arrow is kind of in the way, but it does go through -1, and then it goes through here. Okay, so has everyone got that? 1, so 1 here, because it's actually, the arrow should have made it longer. It's 1 there, 1 there, 1 there, and then 1, 2, 3. So wherever it hits -1, yep, I got them. Wherever it hits -1, got them. Okay. So invariant points, right? The points of intersection. Now let's do the, what's it called? Vertical asymptotes. Vertical asymptotes, wherever it hits 0. So let's start from the beginning here. Wherever it hits 0, I'm going to draw a vertical asymptote. You can count the squares. It's down to across 3. I was trying to make that go exactly through the 8. So I am going to label that as x equals -8. Right? Usually when I'm not trying to trick you with the numbers here, right? So it was trying to get through -8. Yes, label. Go across. Here's another one, 4. So this is x equals 4, right? Label that. Okay, and I see one more here. And this is x equals 7. Yes?
So wherever the graph is 0, it's a vertical asymptote?
Exactly. Wherever it hits 0, yep, it's a vertical asymptote. Yes. Okay. Horizontal asymptotes. Now let's discuss this. So this one has an arrow that's going away forever, right, from the x-axis, away from the x-axis, which means it's getting infinitely bigger there, and that's going to go the reciprocal, which will go towards the x-axis. So yes, there will be a horizontal asymptote on this side at y equals 0. So yes. And then look what I did to the other side. That was your question. What if I put a dot? So it won't go forever. I'm just going to take this dot. So watch this. We're going to take this dot here. Okay? Can I just plot the dot? So what point is this? That is the point 9, 4? 9, 4? Okay? Let's plot it. And where is it going to be now? 9, 4 is now at 9, 1/4. Yes. Right? So that becomes 9, 1/4. And so again, you're just going to kind of make it really low. That's 9, 1/4. So no asymptote because it stops. So it's going to curve down towards it, but we'll stop it at the dot. So it'll curve down towards it. So instead of heading up, it'll head down. So I can even draw that part in. Right? Does that make sense? So look, I know it's going to do this and stop at that dot. So I know what's going to happen there. So it curves down like an asymptote, but it'll stop at that dot from my intersection point. Okay, what else? So I can draw this part. Look, so you can draw it in bits. Look, can I do this? I know it's going to head up. Are you getting used to that pattern? Yeah, so it heads up. So I drew that whole part there. So that part of the graph's done. What about this part? What do I see what's happening here? So what are the 4 steps I'm doing? Asymptote, asymptote, invariant point, and max-mins, exactly. So it's a minimum. So my minimum here is, my minimum there is, I'll write it on the side. So I have a minimum at 6, -2. That's in my head. And what do I actually get? I'm going to get a max at 6, -1/2. So I want to see 6, -1/2, so a dot right there. Okay, so 6, -1/2, perfect. That's a maximum, which also tells me that I know the graph will go like this, right? So we can draw the rest of it. Do I have anything else funny happening? So I'll draw this part. You want to draw this part now? Right, so I know that's a maximum. That's heading towards, so it's now going to turn around and be away. That's my maximum, so see how it goes towards the x-axis? But those numbers are becoming 1/2, 1/4. It's going to go away, so it goes this way. And there's lots of overlap, right? So wherever it's positive, so wherever it's negative, it's negative. It's all going to be overlapping. So I did that part of the graph. Okay. Have I ever in your life, we've had how many lessons together, done a horizontal line? No. What do I do with the horizontal line? It works like the...
Like a max.
Yeah. Oh, no. Doesn't have to be a max. Yes, you can treat it like a max. Yes, so yes, that's one. Yes. So it's like a maximum, which is now going to be a minimum. right? So it's like a long maximum. Also, it's just going to be a horizontal line. So the reciprocal of this is y equals what? 2? Y equals 1/2. So it's going to be this part here. So I'll just draw. This looks messy because I'm just making notes all over it. So this is y equals 2. This is going to be at 1/2. Does that make sense? So it's at 1/2. So if it's y equals 2, I'm going to put my new line here at 1/2. And it'll go from this point to this point. Does that make sense? So here, I like to do it like a point. So see how I got this point, grabbed it, and